Many people say data is the new oil, but is data really the new oil? Can data be as critical and as valuable to our daily lives and our economy as is oil? What do we know about oil? Oil in its raw form comes in different grades. They're made up of different molecular composition and properties, different viscosity and concentration. They also contain some amount of dissolved gas and highly corrosive elements like sulfur acid, which can be quite toxic. Therefore, in order for oil to become useful commodities such as gasoline, diesel, LPG, and other fuel sources, it first needs to be refined, treated, separated, and converted. In such context, data is no different. We've all heard how important data and data quality are to organizations, especially as more and more companies increasingly rely on data-driven analysis and decision-making. According to Gartner, poor data quality can cost organizations an average of $12 million per year, with impacts reaching beyond just immediate revenue, but over the long term likely affecting overheads, overall business decision-making, and causing complexity in the data ecosystems. Gartner also estimates that as of this year, 2022, 70% of enterprises continue to improve and track their data quality metrics to reduce operational risks and costs. Now, bad or incorrect data tends to directly affect the quality of our analysis, insight discovery, and therefore decision making. Colloquial words wisdom, garbage in, garbage out, could not represent more truth in the context of data quality. Imagine running revenue prediction models or risk analysis models on poor quality data. It leaves very little room for confidence and trustworthiness. Alteryx Designer Cloud, powered by Trifactor, helps users to easily understand data quality, define rules that help to govern certain data quality, and as well as track and monitor data quality metrics. Designer Cloud, powered by Trifactor, provides automatic data profiling and data quality detection in conjunction with a very flexible data quality rules engine or framework. Together, these help users to quickly discover and understand their data, determine whether the data is good enough to work with, or certain areas of the data may need correction or transformation. Explicit rules can be defined and applied to automate the detection and monitoring of data completeness, correctness, consistency, and accuracy. As a result of building data quality rules in Designer Cloud, users not only get a better handle on their data quality, they also gain access to the data quality indicators and metrics derived from the rules themselves. Here I have an example dataset consisting of sales records. By previewing the data, I get to see my data profile in the form of preliminary data quality analysis and distribution through automatic profiling. For each column, I get a data quality bar which indicates whether my data is missing or perhaps has some mismatched values or invalid values. Below, it shows me the data distribution histograms that indicate the distribution of the values within my column based on the data type. Let's take a deeper look at some of these columns. As we go into column details of this particular column, we get a lot more information. We get detailed statistics on the left-hand side. We also get to see top values, and if we have any sort of mismatched values, they'll show up here along with the outliers. As you can see here, there's one mismatched value that is supposed to have just numeric values, but yet it contains the letters LBS pounds. Let's take a look at other columns. Let's look into the event time column. This is a date timestamp column. As we go into column details, we get a lot more information. We have top values there. We also have mismatched values that are being surfaced. We've got absolutely invalid records there with error timeout, along with records that carry inconsistent time format. And this is the advantage of Designer Cloud. It automatically highlights this sort of mismatches and data discrepancy to us without us having to do any work. Now let's take a look at specifically the data quality rules that Designer Cloud has built in. To navigate to data quality rule, I click on the icon on top right hand corner. Here we've got a set of rules that have been defined. such as, hey, your total sales cannot be negative, a customer zip code has to be valid, perhaps ship date cannot be earlier than your order date, or for more complex rules such as, hey, the total sale has to be greater than or equal to the unit price multiplied by the quantity, add the tax, and minus any sort of discount. When we create data quality rules, we can go with a set of suggested rules, such as these. As an example, I can enforce a rule that states that customer last name has to have valid values. It cannot contain non-alpha characters. And customer occupation has to fit within a certain set of predefined values. And I want to make sure that my customer phone number is also valid. I'll go ahead and add these rules. Then come back here, and now I can click on my data quality bar to view the filling rows. Records with bad phone numbers, and as well as customer last names that may have problems. In addition to just selecting the suggested rules, I can always define a custom rule or custom set of rules using the logic that would meet my requirements. I can define a rule with nested functions and expressions to allow me to basically construct or enforce the logic of the rule that I'm looking for. Perhaps I want to add a rule where it enforces a 30% margin on my price compared to the cost that I paid or that I incur. In this case, I can say unit price is greater than or equal to my standard cost multiplied by 1.3, which is 30% higher. And now I can add the rule. And now I can see records or transactions where my profit margin is less than 30% and compared to my cost. Now, when you have the rules define your workflow and you run your job, the result is that you get this nice looking profile. The profile is also available in the form of a PDF, which consists of not only the data profiling, but also the set of data quality rules that you have defined in your workflow. In the report, you get full data profiling for each column in your dataset, along with the metrics, missing values, mismatches, as well as valid values. You also have your set of data quality rules with their own metrics, as well as the rule descriptions. You can see that the rules here with percentage of failing rows and those that are compliant. Let's take a look at a more advanced use case that makes full use of data quality rules. Here we have a set of rules that represent the CDAG Audit Protocol, and CDAG Audit Protocol is defined by the Center for Medicare and Medicaid Service to evaluate and monitor the performance of healthcare service providers. Now, organizations that fail to follow the rules may risk exposure to civil money penalties, intermediate suspension of enrollment and payment, or even termination from the program. The set of rules here represent the logic of the requirements mandated by the CDAG Audit Protocol. For each rule, we can click on the data quality bar of the rule to see the non-compliant rows. We also get to view the percentage of rows that are conforming. If we were to check out the rule, you see that the rule was constructed using just basic logic here, a combination of functions as well as expressions that are available in Designer Cloud. Rules can range from very simple logic to a lot more complex set of expressions. Once these data quality rules are defined, the workflow itself can be shared with auditors and reviewers who can come in and make an assessment. They can look at each rule. They can also drill down into the rows that are non-compliant, those that are valid, and they can further generate reports. Now, sometimes there are situations where non-compliant records are identified. Those would then need to be passed to some kind of an audit committee or a functional team for review and correction. For instance, we may need to send bad data records that are in violation of certain data quality rules back to our vendors or to our clients for their assessment and corrective actions before they can be cleared for reprocessing. With the flexibility of Designer Cloud, we could easily achieve this. We have the rules engine that helped us to identify the non-compliant rows for each rule. At the same time, we can use the recipe steps or the logic within recipe steps to associate rule names with the failing rows. We basically take the logic of the data quality rules and apply them as recipe steps. So for each rule, we have a corresponding recipe step which identifies the failure scenario, meaning rows are non-compliant. And for those rows, we then create a new column, or we basically create a new column and then assign the rule name of that rule to the rows that are non-compliant or to the rows that are not passing the rules. Let's take a look at one of these rules to see how we're adding the rule name or attaching the rule name to our new column for the rows that are failing. We're taking the logic of our original rule and are embedding it here. And we're trying to negate the matches on the rule, meaning the rows that are non-compliant, rows that are failing the rules. For such rows, we'll then add the actual rule name to our new column for these rows. For the very first rule, we would create a new column and assign the rule name to the column. However, subsequent rules only require that we set the rule names to that column, given that the column already exists, and the column that we're talking about here is called the error flags. We'll go through and we create recipe steps for all the rules, one per rule, and assign the names to the rows that are non-compliant. At the end of it, we end up with this column here. This is called the error flags column. I just gave it a name, error flag. We just need to do a little bit of cleaning up in this column by removing the leading commas, and this is done through step 30, as you can see. Now what we need to do next is take this list of values and turn this list into an array type structure. With the array type, we can then filter out the values within the column very easily. Now to turn this column into an array structure, we simply click on the column, scroll down to the very last suggested transformation, which is the nest columns, convert error flags to array. Click on that. We can see that we can now access the attributes or the values within that array object. Now once I have this column, which is in the array format, I can filter the rows by a set of rule names or by a particular rule name by simply clicking on the histograms here, and on the right hand side selecting keep rows. And at that point I can click run to generate the dataset that contains all the failing rows for the rules that I have selected or that I have filtered. Now there's another way to filter the failing rows by rules and generate the output datasets that would contain the non-compliant rows.
This is using the recipes itself within the flow. I basically made a copy of the main recipe here. This is called all rules. But with this recipe, what I've done is that I've removed all the filters on the overall recipe. And then from there we can branch out for each rule. For each rule name, we filter out the rows by its rule name and create the output. I've created here a sample of 3 different rules. To show you how this works, you can make a duplicate of one of these rules with input. Bring it down here, just rearrange it quickly. We can now open this up. Drop the filter that has a previous rule name, and now select on the rule name that we desire and add keep rows. That then gives us the new rule with the output that is filtered just based on the non-compliant rows for that particular rule. And we can rename this to be, say, call it rule N. Okay. And of course, there's also the third option. The third option is that for each workflow, we have the ability to define what we call input parameters. Here I've defined a parameter that has a list, and this list contains the rule names. You can see here of the different rule names. By selecting on one of these rules and do a save, when I come to running the job on this main recipe, the filter itself will get applied. And the way we can apply that filter is by opening this up. Scroll down to here. Instead of setting it to an explicit rule name, you can see that I've set it to a variable name, which is called CDAG rules. This variable name here itself is the list of input that we saw earlier, which is a list of rule names that we defined via the input variable. And at runtime, the workflow itself will take the values set to the input variable and apply it to the filter which we have, and that will generate the corresponding output with the non-compliant rows for that particular rule.
As you can see, with Designer Cloud powered by Trifacta, users can easily define data quality rules that can help to monitor and govern the overall data quality and correctness. Also, recipe steps can be implemented to filter rows to generate output datasets for the non-compliant review and assessment. You can use one of the three methods explained to filter the rows for each rule. One is by using a filter directly inside of the recipe. Second is by creating separate recipes where each recipe represents the filter of a particular rule. And third is by creating an input variable which is in the form of a list. Check out Designer Cloud powered by Trifacta for your data quality needs.